Hi everyone, so in my previous video in the mole I showed how to work out number of moles, and I briefly went over mole calculations with equations. So when you write your equation out, calcium plus hydrochloric acid becomes calcium chloride plus hydrogen. You must always write the mole ratios first. 1 mole calcium, when it's balanced, so you get one calcium there, two hydrogens, two chlorides there, two chlorines there, and two chlorines there. So you end up with 1 mole calcium, 2 moles of hydrochloric acid, 1 mole calcium chloride, 1 mole of hydrogen, okay, gas. So you always write the equation, balance it, then write the mole ratios, okay? Right, question we want to ask is, if you have 3 grams of calcium, how much calcium chloride will be made? Okay? So how much of that will be made from 3 grams of this? So, and it's not as simple as just saying 3 grams, because it's 1 to 1 mole, 1 mole to 1 mole, therefore 3 grams of calcium will make 3 grams of calcium chloride. That is not how it works, okay? Some people make that mistake. So firstly, I've written the equation out again so I can do this calculation a bit more neatly. So you write the equation out. You can write 1 mole of calcium creates 1 mole of calcium chloride. You then write down the mass of 1 mole, which is 40 grams of calcium, which you can get from your periodic table. Okay? Here. So the mass of 1 mole of calcium is 40 grams. That gives the mass of 1 mole of calcium chloride, which is 111 grams. Okay, work out from the mass of calcium, which is 40, plus 2 chlorines, both chlorines 35.5. That adds up to 111 grams. Okay, so so you write 40 grams produces 111 grams. Therefore, 1 gram. If you divide both sides by 40, 1 gram gives 111 divided by 40, okay? Then if you divide 111 by 40, you get, we can do it in a minute, you get 2.755, but we'll worry about that in a minute. And then because you got 1 gram giving this, we want 3 grams, so you go 3 times 1 gram gives 3 times this, which equals 8.3 grams, okay? So that's how you do it. Write down that, 1 mole to 1 mole, 40 grams, 111 grams. So 1 gram gives 111 divided by 40, divided both sides by 40. So 3 times this will give 3 times this, which is 8.3 grams, okay? So 3 grams of calcium will give 8.3 grams of calcium chloride. Okay? Right. Next example. If you have hydrochloric acid and sodium, okay? Reacting to give the salt, the sulfate, sodium, plus hydrogen, okay? Gas. I've not written down the state symbols here, but it's not that critical, but that would be solid, aqueous, solid, and gas, okay? So, writing it again, 2 moles of sodium. If you write the equation, balance it, 2 moles of sodium, 2 sodiums, 2 hydrogens, 1 sulfur, 4 oxygen, 4 oxygen. So you get 2 moles of sodium react with 1 mole of sulfuric acid, produce 1 mole of the sodium sulfate, salt, plus 1 mole of hydrogen. Okay? So if you have 5 grams of sodium, how much of sodium salt will be made? Okay? So how much of this will be made? Sodium sulfate. So we know that sodium is 23 grams per gram formula weight is 23 grams per mole, okay? That sounded confusing. Sodium is 23 grams per mole. 23 grams is the gram formula weight. So 2 moles is 46 grams. So if you write that exactly below, 46 grams of sodium here produces 146 grams of sodium sulfate, okay? The mass of this adds up to 146. 2 sodiums is 46, plus sulfur is 32, plus 4 oxygens is 64, okay? 16 grams for oxygen each oxygen atom, so that adds up to 142. 6, 10, 12, 10, 13, 14, okay? So 146 grams of sodium produces 142 grams of sodium sulfate. Divide by both sides by 46, okay? You 1 gram therefore equals 142 divided by 46. So 5 times this, because we want to know about 5 grams, 5 times this produces 5 times this, which equals 15.4 grams, okay? So therefore 5 grams of sodium produces 15.4 grams of sodium sulfate, okay? This is very easy, once you get used to doing this, write the equation, balance it, write the mole ratios, then write the mass for the number of moles there and the mass for the number of moles here, and then just work this through is a very easy way to do it, okay? Next example, aluminium plus iron oxide becomes iron. The aluminium plus iron oxide becomes iron plus aluminium oxide, okay? So if you use 2 grams of iron oxide, how much iron is made, okay? So I'm writing this down again neatly to make it clear. So this is balanced. You've got 2 aluminiums here. 2 iron here, 2 iron there. 3 oxygen here, 3 oxygen there. So we know that 1 mole of iron oxide leads to 2 moles of iron. It's not necessary to always write down all the mole ratios. Okay? If you can just go straight to the atom or compound of the molecule that you know about, and just the one that's the unknown, okay? So there are 2 moles of this and 1 mole of that as well, but there's 1 mole of iron oxide and 2 moles of iron, okay? So 1 mole of iron oxide weighs a total of 160 grams, and 2 moles of iron weighs 112 grams, okay? Iron is 56 grams, so there's 2 of them, 112, and oxygen, 3 times oxygen is 48, adds up to 4, 5, 6, adds up 160, okay? So 1 mole leads to 2 moles of that, 160 grams leads to 112 grams of this, so divide both sides by 160. 1 gram of iron oxide leads to 112 divided by 160, okay? That's 112 divided by that. So therefore 2 grams of this, that's 2 times this, because that's what we want, okay, here. So 2 times 1 gram equals 2 times all this, which equals 1.4 grams, okay? So therefore 2 grams of iron oxide will make 1.4 grams of iron. This is exceedingly useful, this method, because you can go either way. If you want to make 1,000 tons of this in industry for building bridges and stuff like that, or making planes, like they're made of stainless steel, well, various, not planes, but if you want to make 1,000 tons for commercial reasons, you can work out how much of this you need to dig out of the ground, okay? Or you can go that way. If you have, say, 100 grams of this, or if a factory is 50 tons of this, you can work out how much of this you'll get, okay? So if a factory is 50 tons of this, or you say 500 kilograms, 500 kilograms is not 50 tons, I don't think. There's 1,000 kilograms in a ton, so 50 tons will be 5,000 kilograms. So if a factory is 5,000 kilograms, it would tell you how much, you can work out how much of this will be made. But if you have to make, say, 1,000 tons of this, you can work out how much of that you have to start off with, okay? So it's very powerful. This is a very powerful way of working out unknowns. And in the laboratory, it's the same. If you want to make 100 grams of iron, you can work out how much of that to start off with. Okay? Same with this. If you have 10 grams of aluminium, you can work out exactly how much of this you'll get, or that. So the aeroplane industry would probably want to know how much aluminium it would need to make planes. So if it wants to make 1,000 tons, it could then work out how much of this you need to make 1,000 tons. Okay, I think airplanes made of aluminium and stuff like that, light metals. So if you have 2 grams of iron oxide, how much iron is made? So yeah, so I just worked out 2 grams of iron produces 1.4 grams of, sorry, 2 grams of iron oxide leads to 1.4 grams of iron, okay? So yeah, this is it's a very powerful method for working out problems in chemistry and sort of material industry. If you want to become a material chemist or industrialist, this is exactly what you need to learn. So what was I doing there? I think this was oh yeah, I was going in reverse. That's what this was doing. So I wrote the same equation, but starting with this and going that way. If you want to know how much of this you'll get if you started with 1,000 grams of iron, so I'm taking 1,000 grams of iron, which is 1 kilogram, okay? How much of this will be made? So 112 grams of iron, at least 160 grams of iron oxide, okay? So 1 gram, let's divide both sides by 112. These two, 160 divided by 112. So 1,000 times this is 1,000 times this, which is 1,428.6 grams, okay? 160 divided by 112 equals times 1,000 equals 1,428.6 grams. So if you take if you take 1,000 grams of iron, or if you want 1,000 grams of iron, we know that we need to start off with 1,428 grams of iron oxide, 1.4 kilograms. So to make 1 kilogram of iron, okay? So you need to start up with 1.428 kilograms of iron oxide to make 1 kilogram of iron, okay? So this is an immensely powerful way of working with chemistry to work out quantities that you need. Okay. Goodbye for now. Oh, please like, subscribe, comment, press bell. Help me get to 50 subscribers. Thank you very much.